how to really know that your decision is right. What is the proper way to get this ancient knowledge? Just use some benchmarks. Easy, right?
Not at all. I do not like the modern ways of synthetic benchmarking. Abstract numbers, useless scores. Over 9,000 Geekbench points, 2168.3 budget system points. What does it all even mean? How to translate it into real-life application? After spending multiple weeks of constant research, watching hundreds of videos, I got confused and realized that I still do not know which computer is better for me and what to buy. That's why I decided to take a destiny in my own hands and have constructed my own way.
The real alien computer testing.
9 circles of real-life world applications with results that is easy to understand, that translate into time spent to finish the task. Real hours, minutes, seconds, instead of abstract numbers.
1. 3D renders and animation. 2. Video composing and VFX. 3. Video editing. 4. Audio editing and music. 5. Photo editing. 6. AI photo and video upscaling. 7. AI stable diffusion photo and video creation. 8. Handmade programming code on Python, C++, and Java. 9. Game development on Unreal Engine and Unity.
9 layers of real-life working applications. And not only that, there are 2 additional layers.
10. Gaming. We will test lots of synthetic games from 3D Mark. And 18 real games in total in extremely in-depth tests like never before. 11. Battery life. Fan noise and temperatures. Utility test for comfort of use.
And bonus, 12. Music test, to stress test speakers and sound quality. I split all these tests into 3 levels of difficulty: easy, medium, and extreme. They are called toaster, human, and alien levels. Toaster level computer. It is not very impressive, but at least it can make you a toast. What else can you expect from a cosmic toaster? Human level computer. It is the minimum of what a self-respecting human being wants from a modern machine. Alien level. This title is given only to a cutting-edge technology, impressive machines ahead of a curve. This way we can get even more understanding. Do we need to spend extra money when our goal is only lightweight work? Or maybe we need a computer to be powerful only in one specific area, but others can be not in priority. This way saving 1-2 minutes in rendering time, but paying couple of $thousands more won't make much sense. On the other hand, saving hours and hours of life on rendering each and every day cannot be valued by any price. In the end of the tests, I will give separate scores for easy, medium and high levels, and overall scores as well. This way we can test all old computers of the past and all new machines from the future in repeatable, reasonable, equal way, and make a list that will tell us exactly what to expect from each in terms of real-life performance. There are 2 secret levels for data PC. It is given to the very weak or outdated machines, pathetic. And wait, computer, what are you? This does not look like anything. The machine outside the boundaries of our reality. Not only that, but we will test it in different power consumption modes: turbo, balanced, silent, and silent plus iGPU, with dedicated NVIDIA AMD GPUs turned off.
If all that do not impress you, I do not know what will.
I will also introduce a curse debuff system. If a device cannot handle the task properly due to freezes, forced shutdowns, or errors, it receives a curse. The curse strength is given as a percentage, which defines the worsening factor.
Curse strength in percents means that the result becomes several times worse. For example, a 300% curse means the result is 3 times worse, worsening factor of 3. A 3,300% curse means the result is 33 times worse. I think you know the drill. How worsening depends on the type of metric. For metrics where lower is better, such as time to complete, we multiply by the worsening factor. For metrics where higher is better, such as frames per second, we divide by the worsening factor. If device have problems during the task, worsening factor will be applied to the results of that exact device. In other cases, the debuffed result is compared to the weakest performance among all currently tested devices. The device with the curse will perform exactly X times worse than that weakest baseline. This system is designed for unforeseen consequences that are outside of our control, to be accounted also. Device that causes constant repeatable errors can't be ignored.
Let's dive deep in, and I will explain it in the great details, what each circle of tests consists of.
First circle of tests. 3D renders and animation.
I will use 3 programs: Cinema 4D, Blender, and Houdini.
Cinema 4D program.
One of the most intense 3D scenes, Alien Spheres from Alien Technologies. It uses multiple reflective and complex textures, portals for light rays to jump through. Extremely hard test for global illumination, ray tracing calculations. Cinema 4D till this day does not have a native physical render engine.
Of course it is all about the GPU. Physical render of Cinema 4D can utilize CPU and CPU only. We need external solutions to use graphical cores.
Redshift, Corona, and Arnold. I chose Arnold Renderer. It will stress test not only the raw compute powers, but VRAM capacity as well. I will render it in 4 different resolutions: 2K, so-called 1080p, 4K, 8K, and the whopping 16K render that lots of 3D artists use for the final, highly detailed delivery. Easy. Toaster level is 2K. Pixelated but can be easily used as wallpaper images on 1080p monitors or web pages. Medium. Human level. I will use 4K and 8K render times for this more demanding task. Extreme high. Alien level will use 16K render. Physical render engine will choke any toasters with low amount of VRAM and will show the true potential of modern machines.
Next will be Blender, a new shining star on the market. Swiss Army knife of 3D programs. It will have 3 subcategories inside. Basic image renders. Animations of 240 frames, 10 seconds of each. And third, calculation of particle simulation.
For single image renders, I will use 3 scenes: Junk Shop, Monster, and Alien Spheres. Junk Shop is plain and simple. Monster scene is more complex and designed to showcase subsurface scattering. Alien Spheres, the most harsh stress test for ray tracing and global illumination, the real torture for a GPU.
It will be the same way. 2K, 1080p for web delivery. 4K for high-fidelity wallpapers. Modern 8K image. An extreme 16K professional delivery. Physical render of Blender is called Cycles. Will be used on all, using GPU, with 256 steps.
For easy toaster level, I will use 2K resolutions of all 3 scenes. For medium human level, I will use 4K and 8K of all 3 scenes, because humans deserve to have better. For high alien level, I will test 16K resolution render on all 3 scenes. Now, next will be moving pictures, animation. I will use 2 scenes: Ripple Dreams, a lightweight straightforward test, and very complex Cosmic Fluids, a project from Alien Technologies, extreme benchmark with big spike of performance and ray tracing depth. Animation can stress test not only raw GPU power, but an ability to communicate with RAM and SSD disk. All 2 scenes will need to be rendered in 240 frames, 24 FPS, 10 seconds video. Cycles renderer will use GPU with 32 steps for Ripple Dreams, and with 64 steps for Cosmic Fluids. GPU noise reduction will be used on both. The same logic for scores: 1K renders for toaster level. For medium human level, I will use 2K, 4K, and 8K for Alien.
Bonus round for Blender! CPU computation of fluid simulation. Not everything in 3D space revolves around GPU.
Cosmic Fluid scene has 3 levels of difficulty. 1 flow of fluid with low amount of particles as easy toaster level. Medium human level will double the flows of fluid and double the amount of particles in them. Hardest alien level will have 3 flows of fluid and triple amount of particles, for the most realistic and complex splashes and drops. Very strong and can make a computer to freeze with error.
But no simulations can be talked about without next program. Houdini. The real magician among all 3D apps. You can do so much more with it, but it is mostly well known for its particle simulations. Real CPU stress test.
We will have Alien Water scene as our test subject. Single flow of water with low amount of particles for toaster level. Double of flows of water with double amount of particles for human level. And triple amount of water flows with quadruple amount of particles, alien level. All results in 3D single images animation, and simulations are measured in total time needed. Computer that finishes the work faster is stronger. The lower the graph is, the better. If the task cannot be done, device will get 200% curse debuff for the task. If it crashes the app, it will get 300% debuff. If it crashes the whole system, it will get 400% debuff. Because it is not only failed the task, not only we need to restart the computer and the app, but we need to find the workarounds to deal with the error. If device cannot use GPU and falls back to CPU, the curse is not being applied, because CPU fallback is a debuff in itself. So, that's it for 3D renders and animation. 3 programs: Cinema 4D, Blender, and Houdini for extremely deep benchmarking.
Next second circle of tests. Video composing and VFX. We will use 2 programs: mainstream After Effects and industry standard NukeX.
After Effects is using layers, while NukeX has node system. But for scoring, they will be identical. I made 6 scenes with 30 seconds clips that are getting more and more hard, with more effects and more layers and nodes. Each scene gets more complex than previous. Basic, Advanced, Extreme, Celestial, Insanity, and Void. Basic is the easiest, while Void is unreasonably too hard and unrealistic, designed to break weak minds, unprepared of great dark beyond. Basic level will have general 30 FPS on a 4K 60 timeline with simple plain text. Advanced level will have double the speed to get 60 FPS, more manipulations with video, with faster moving text and small noise reduction. Stream level will have color correction, LUTs, additional layer of video on top, more noise reduction, and more complex text movements. Celestial test will have even more layers of video files of various codecs, additional effects, green screen removal, more noise reduction and double the text. Insanity level test, even more layers of additional video with even more codecs. The difference between hardware decoders starts to vanish. More effects and more noise reduction, quadruple the text with more complex movements, and now we're having double upscaling of main layer. Void level test. No weak-minded humans are allowed in this dimension of cosmos. Even more color correction, with even more effects, more noise reduction, endless amounts of videos with various codecs. Hardware decoders are no longer responding. Double of green screen removal, text is out of control. Main base layer has 4 times upscaling. This test can push even alien-level computers to its limits, and is stepping on the void-level computers. No cosmic toasters can handle it. Potato PCs are disintegrated on place. Total madness for unprepared beings. So, 6 levels in total for After Effects, from basic to void. And 6 levels for NukeX.
But how are we gonna test it?
Before you even start rendering, you need to work on the timeline and play back the results. Both After Effects and NukeX needs to buff a portion of timeline. It is not real time, and it shows you each and every frame of your playback from that buffer. The faster it computes, the quicker you will see the final results. To test it, we will measure the time it needs to buffer 2 seconds of video. 120 frames. It can compute faster than real time, and you will get immediate results. Or it can compute for several minutes, and you will be able to play back those 2 seconds only after long waiting. Both After Effects and NukeX allow us to lower the playback resolution of the timeline. We can use full 1:1, or lower it in half for faster playback speed, or even 1/4, 4 times resolution reduction. We will test all 6 levels from basic to void in 3 resolution levels, full, half and quarter, 18 runs in total. For low toaster level, we will test all 3 resolution scalings on basic and 1/4 resolution of advanced, because even toasters can have a chance. For medium, human level, we will test the whole extreme, up to half a resolution of celestial, because humans inherit what is above. For extreme alien level, we will test celestial playback for the full resolution, as well as insanity and void on all 3 scaling resolutions. After we are satisfied with the results, we need to somehow create final video files that we can use, export and render. The proper and most efficient way of using After Effects and NukeX is to export video in PNG or JPEG, static image sequence, like roll of film. But normal humans never do this, only professionals and people from cinema industry. So we will export it more conventional way, I will export each of 6 scenes into codecs, highly compressed H.264 and ProRes in proxy. This way we can utilize encoders as well. So, there will be 12 exports for After Effects and 12 for Nuke X, 24 exports in total. Results will be combined, so you don't have to calculate all that. For toaster level, I will use basic and advanced tests, because even toasters need their headroom for improvements. For human level, I will use extreme and celestial, because humans deserve better and despite all have a place in the skies. And for alien level, I will use insanity and void. True aliens can handle the madness of the outside great beyond. Cosmic horrors becomes nearly a distant whisper.
And there is bonus round.
For After Effects, I will test stabilization, warp stabilizer, to make shaky footage more smooth.
Also, we will test camera track for After Effects.
And for Nuke X, I will test camera track and planar tracker to calculate scene depth and place a layer inside our scene. Both of these bonus tests will utilize CPU. Everything in both programs, playback, export, bonus rounds, is measured in total time needed. Computer that finishes the work faster is stronger. The lower the graph is, the better. Your debuff logic is the same, and will be the same on all tests that we will describe further. If not, I will explain the nuances on that section.
Next third circle of tests. Video editing.
For this, I will use 2 main and the most popular and used programs, Adobe Premiere Pro and DaVinci Resolve. They both use track systems that act like layers. It will have the same logic as video composing. 6 handcrafted separate scenes that will become increasingly more complex. This time, clips will be 2 minutes in length. And main difference is that instead of one H.264 file, we will use all codecs possible. ProRes as the least compressed, 8-bit H.264 for some compression, 10-bit H.265 for even more compression, and my favorite, AV1 for even more stress. Good video editing machine absolutely must accept anything I load on it. Not only that, but we will use audio effects and such features as voice isolation. Because good video consists not only from visuals, but good audio plays even more important role. Basic test. 4K 30 FPS on a 4K 60 timeline, with basic log conversion LUT on 10-bit H.265 file. Plain simple text. Very small levels of noise reduction. One audio track with small amount of voice isolation. Advanced test. Video has 2x speed to get 60 FPS. More manipulations with footage. More advanced color correction. More noise reduction. Text movements are more advanced. 2 tracks of audio with more effects. Extreme test. More video tracks with additional codecs. More noise reduction. More advanced text moves. 3 audio tracks with even more effects. Celestial test. Even more video tracks with more files. Green screen removal. Double the text. More noise reduction. More intense audio effects. Insanity test. Even more video tracks. Line between hardware decoders starts to vanish. Quadruple the text. More noise reduction. 2x AI upscaling of the main video track. 4 audio tracks with more effects. This place will break unprepared human mind. Void test. Extreme amount of video tracks of various codecs. Hardware decoders lost all its advantages. Double amount of green screen removal with more VFX. Extreme amounts of noise reduction. Text is spirals out of control. 4x AI upscaling of the first main video layer. 5 audio tracks with insane amount of effects. This place is strange and echoes through your whole existence with distant chorus. Only prepared aliens can find their way through this cosmic void, even in the afterlife. So, 6 tests get progressively harder for Premiere Pro, and 6 for DaVinci Resolve.
Sounds like a lot. Is it all?
Actually no, there is more. I have additional bonus tests. They are called Project B and Project A+. They are designed to add high-resolution images in your video editing scene. Images fly across the screen, stress testing VRAM, RAM and SSD disk. Those projects are 5 minutes in length. Project B is more lightweight, while Project A+ has double amount of images, more video tracks, and 1 additional audio track with more effects.
How are we gonna test it? Guess the same way as video composing in VFX.
Close, but not exactly. First of all, I will test timeline playback. For example, Premiere Pro. It is quite different to something like After Effects and Nuke X. After Effects plays back not in real time. It needs to buffer first, and then show you smooth playback. While Premiere Pro and DaVinci Resolve plays your timeline in real time immediately. If the powers of computer are high, you will get smooth playback on your screen in real time, 60 frames per second. But if computer is not so powerful, you will get less than real time. For example, only 20 FPS out of 60. We will press play and we'll see what are the results.
Each level among 6, from basic to void, will have 4 video files with different codecs: ProRes, H.264, H.265, and AV1. Both Premiere Pro and DaVinci allow us to lower the timeline resolution with scalings. We can use full 1:1 pixels, lower it in half to 1/2s, or lower it even more 4 times, quarter of the full resolution. We will test the playback of all the 6 scenes for both apps, in 3 different resolution scalings, in 4 codecs: ProRes, H.264, H.265, and AV1. Except Premiere Pro, it won't have AV1, because there is no support for it, while DaVinci Resolve has it.
Project B and Project A+ won't participate in playback test, only expert. So, I will test 54 runs for Premiere Pro and 72 for DaVinci Resolve. 126 rounds of playback in total for each computer. But do not get overwhelmed. I will unify everything and in the end you will just get an easy to understand single number. For low toaster level, we will test all 3 resolution scalings on basic and 1/4 resolution of advanced. For medium human level, we will test full extreme and up to half resolution of celestial. For extreme alien level, we will test celestial playback for the full resolution, as well as insanity and void on all 3 scaling resolutions. Video editing has a secret level test called Potato. Video on this project does not have any effects on video and audio whatsoever. No noise reduction, no nothing. Even outdated 2020 devices with integrated iGPUs will have real-time 60 FPS. Truly useless potato test. If device will have anything less than real-time, it is really a potato. But there is a small for first glance, but very huge problem in this method. Lags, stutters and freezes. 10 smooth FPS is several times better than 40 laggy FPS that have freezes and stutters on top of it. Because in case of smooth 10 FPS, you can edit your video with no problem. Well, even though you get 40 FPS out of 60 in the second case, but stutters and freezes make it almost impossible to edit and to understand what is going on your timeline. Also, there is situation when the program shows that playback is in full real time, but you can see that it is not. There is occasional stutters here and there. That's why I have to introduce Curse debuff system that is dedicated to video editing playback only. It consists of 9 situations. You need a sharp eye to make it work. Likely, I have one.
Level 0. Barely noticeable lag. You can spot that something is off, but no impact on the editing process whatsoever. This level 0 will get 5% debuff, so 60 FPS will be 57 in this case. I think you know the drill. Level 1. Very small lag, visible, but still no impact. 10% curse debuff. Level 2. Noticeable lag that starts to affect editing. More drastic 40% debuff. Even though program shows 60 FPS, the result will be 36. But keep in mind, that 36 smooth frames will always be better than 36 result from debuff. Level 3. Very big lag that makes edit uncomfortable. 70% debuff. Level 4. Extreme lag, almost impossible to edit. 600% debuff. Level 1F. Playbacks couple of frames, but freezes after. 2000% debuff. 20 times results reduction. Level FF. Full freeze. Cannot playback anything at all for more than 15 seconds. We will flatline give it minus 60 FPS. If plus 60 FPS is the ceiling for smooth real-time playback, minus 60 is the ceiling for fully freeze unplayable timeline. Level FX. Freezes and shuts down. Program closes down silently or with error. It will get negative 120 FPS, 3 times worsening from perfect score. Annoying when this happens. You need to restart an app and find the solution. Level XX. System crash with device turning off. Minus 180 FPS. 4 times less than perfect score. It happens very rarely. But when it does, you need to waste your time waiting for the whole restart on top of all previous problems.
It looks extremely complicated for the first glance, but you will get used to it fast. It will give a realistic, measurable playback with all freezes, lags and stutters in mind. You do not have to calculate anything. The final results will take account for everything. All these tests are very in-depth, but designed to give easy and readable conclusions with final scores that any person can understand. After we are satisfied with the results, we need to get final rendered video file. We will export it. And to get more data, we will export all 6 scenes by using 4 codecs: ProRes, H.264, H.265 and AV1. DaVinci Resolve can export in all 4 codecs, but Premiere Pro does not have native AV1 encoding option. That's why I will use third-party add-on called Vocoder that allows to use AV1 even on Premiere Pro. For Toaster level, I will use Basic and Advanced Test. Let's give Toaster a chance. For Human level, I will use Extreme and Celestial. It is the minimum that we can agree upon, and I will add Project B on top. For Alien level, I will use Insanity and Void. Madness of Outside Great Beyond shows a true potential of a being. Also, Alien level will get Project A+.
So much is going on. Are we finally over with video editing?
Almost. Bonus round. I will test stabilization of the shaky 10 minutes video footage on both Premiere Pro with Warp Stabilizer and DaVinci Resolve with native stabilization compensation to make it steady and smooth. And second, bonus round.
Insane. Just stop.
Audio expert performance, 3 levels, Toaster with 10 minutes 2 audio tracks and low amount of effects. Human level with more dense 3 audio tracks and effects such as voice isolation. And Alien level with full 5 tracks and extreme amount of effects for audio restoration. We will just export them in 24-bit WAV format. When we are testing playback of the timeline, the higher and smoother FPS, the better, so the longer the graph is, the better. When we are testing export and bonus stabilization, the faster, the better, so shorter graphs show more powerful machine. First debuff logic is the same, except playback. We already discussed it, so that's all for video editing section.
Finally! I thought it never ends. Next, 4th circle of tests. Audio editing and music.
It will have 2 parts: audio editing inside free open source app called Audacity and Audition from Adobe, 2 most used apps for recording, editing and restoring audio. 3 levels of difficulty: export of 32-bit float audio file of 1-hour podcast made from 3 stereo tracks. Easy level for Toaster, no effects, just simple export. Medium level for Human, some effects on the tracks. For Extreme Alien level, double amounts of effects. It is simple and straightforward, we are just exporting the audio. And bonus rounds for both. For Audacity, I will use noise reduction. It will analyze the noise patterns and apply the noise reduction. I will just combine both results spanned to get an unified time. For Audition, I will test Remix feature. It analyzes the music and loops it to prolong its duration. First step, it analyzes the waveform, and second part, it applies the remix. I will combine both results. Both bonus rounds will go to the Human level. And next, music. Music is the language of the universe. We will test 3 programs for music creation: FL Studio, Ableton Live, and Reaper. It is the most popular apps. There is 3 scenarios. For Toaster, no effects, just simple export of 1-hour project with 3 tracks on it. For Human level, some effects on the tracks to make it harder. And for Alien level, triple the amount of effects, even more extreme conditions. Some VST plugins can really put CPU on its knees. For example, restoration plugins from Isotopes RX Elements, or SUSI 2 from OX Sound, but I will not use external VST because of its unpredictable nature. All plugins and effects I use are native for its apps. Effects on FL Studio projects comes from FL Studio. Effects from Ableton comes from Ableton. Reapers are from Reaper. This way we can stress test not only the export time, but get a general understanding of real-time playback. But honestly, you need to quadruple the Alien level test to even start choking the playback. If audio playback is bad, you are owning a truly potato-level PC. Testing will be simple. We will export 3-level test in 3 variants: in uncompressed 32-bit float WAV file, FLAC format with lossless compression, and fully compressed 320 kilobit MP3 file that will stress test CPU little bit more. 27 exports for each machine. Honestly, music creation is solved for years. And for the most part, we are looking at anomalies and weird behavior.
Looks fine to me. Next, 5th circle of tests. Photo editing.
For images, I will take mostly used programs: Adobe Photoshop, Lightroom, and my favorite, Capture One. I will take 144 fully edited RAW files from various mirrorless professional cameras with all corrections and noise reduction, and just export them. For toaster level, I will use 6K resolution, so-called 24 megapixels, from APS-C size sensors of such cameras as Canon M50 Mark II, Sony ZV-10. For medium human level, I will export 8K resolution, so-called 15 megapixels. And for alien level, hard test, I will use 12K resolution, so-called 100 megapixels, from medium format Fujifilm GFX camera.
Will there be any bonus rounds?
Of course, bonus round. I will make an HDR panorama from 45 images of 6K resolution, 24 megapixels RAW files. Program will analyze, then stitch together and export a giant high-resolution HDR RAW file. And I will repeat this process on all three programs: Photoshop, Lightroom, and Capture One.
Sounds cool.
Both exports and bonus panorama stitchings take some time to finish. The faster, the better. Thus, shorter the graph, the more power the machine has. Earth's debuff system is without any changes.
Perfect. Faster. I need a coffee break. Sixth circle. AI photo and video upscaling. For this test, we will use Topaz Labs programs: Topaz Photo AI and Topaz Video AI.
This test is also easy and straightforward. There will be two parts, photo and video. I will use 44 JPEG images of various resolutions and apply denoise, sharpening, and 4 times upscaling to each. Toaster level will export 44 1K resolution images, very small pixelated web files. Human level will upscale 2K resolution detailed wallpapers. And alien level will upscale 4K high-fidelity files to make them even more detailed. To stress test RAM, VRAM, and GPU compute powers. As for the video, I will use Topaz Video AI and make it 2 times upscaling of resolution with General Proteus model, and frame interpolation for more slow motion to get more FPS with Apollo model. I will use 3 files in H.264, H.265, and ProRes 422HQ codecs with 25 FPS to export them in enhanced form. For toaster level, it will be 480p low-resolution files with 2 times upscaling and 2 times more FPS. For human level, it will be 2K so-called 1080p files with the same 2 times upscaling and 4 times slow motion. And for alien level, I will use 4K files with 2 times upscaling and 8 times slow motion, extreme stress. Both photo and video AI upscalings take some time to finish. The faster the better. The shorter the graph, the more powers the device has.
Next, 7th circle of tests. AI stable diffusion photo and video creation.
This test is more complicated. It will be 2 parts, for images and video. I will use Comfy UI and bare-bone Stable Diffusion models, without any add-ons, LoRa's or ControlNet, as it is. Each model will be harder and will require more GPU powers, RAM and VRAM, linear progression. For image creation, I will use DreamShaper as a Stable Diffusion 1.5, lightweight easy model, SDXL, more demanding model with dedicated refiner, and 2 very complex ones, Stable Diffusion 3.5. And the most demanding FluxDef model. Both are using full-sized unbinned safe tensors files and full-sized text encoders.
Totally 4 models, but Stable Diffusion 3.5 and FluxDev will have a small bonus. Bin scaled versions with lightweight safe tensor files, and scaled low file size text encoders that require less RAM and can be used on less powerful machines. So in the end, we will test 6 models, and each will have 3 sublevels of difficulty, 3 resolutions. They will differ from model to model, because they were trained on different resolutions and works the best with only them. For example, DreamShaper will have 256 on 256 pixels, 512 on 512, and 768 on 768. Stable Diffusion XL, on the other hand, starts from 512 pixels and can be used up to 1,536 on 1,536. Some models allow to go above the limits. This way we can test in upscaling capabilities. You can see what resolutions will be used on your screen. To make it simple, low, medium, and high resolutions, 3 levels, 18 generations on each machine.
For toaster level, I will use SD 1.5 on all three resolutions and low resolution of SDXL. For human level, I will use medium and high resolutions of SDXL, low resolutions of both SD 3.5 and FluxDev, and as a bonus, low and medium resolutions of both scaled lightweight SD 3.5 and scaled lightweight FluxDev. For alien level, I will use medium and high resolution of both SD 3.5 and FluxDev, and as a bonus, high resolution of scaled lightweight SD 3.5 and FluxDev. Nothing complicated, we will just use the same prompt across all machines and create stably diffused images.
And next part, video creation.
For creation of moving images, I will use 4 models with the same logic of more harder progression. With each model, we will need more graphical powers, VRAM and RAM. Video light tricks, so-called LTX video, a very lightweight and fast model. Stable diffusion video, so-called SD video, more demanding but very versatile model. And 2 very complex ones, Hanyuan model. And the most demanding and powerful, 2.1. Totally 4 models and 1 small bonus one, scaled lightweight 2.1. For computers with less powers and less RAM. In the end, I will test 5 models. There will be 2 variants on each, text to video and image to video. So basically, first we will transform words into video, and second, we will take already existing image and transform it into moving animation. Scaled 2.1 will have additional super scaled text to video variant with both lightweight scaled checkpoint and lightweight text encoder. There will be 11 video creation tasks rendered on each machine. And of course, bonus round! As a 12th generation task, there will be very powerful, relatively new RainPack. This app generates long-term quality animations from images. I will measure the time that it takes to load all 25 steps 4 times in a row. Toaster level will use light tricks LTX video. Human level will use stable diffusion SD video, bonus RainPack, and 2.1 super scaled text to video. Alien level will use Hanyuan and 2.1, as well as scaled versions of 2.1. Both image and video generations take some time, so faster the better. The shorter the graph, the more powers are inside.
Let's go further. 8th circle of tests. Programming and coding.
This section is very interesting. What does programming and coding even mean? There are 3 major environments on our systems: Python, C++, and Java. Everything we use on our computers, all apps are in one way or another, are based on the code written inside these environments. All previous circles are also programming and coding tests in a way. But I want a direct interaction with code written by a user. That's why I have created a handmade custom code for each of the 3 major environments. Tasks that take time to finish and give me a result as time. I am not a working professional in IT coding sphere, keep this in mind. I have applied my own knowledge that I have. I have created 7 coding tasks for Python and C++, and 9 coding tasks for Java. First 3 tasks are designed to stress test CPU. They are similar in its nature on all 3 coding languages. 1 test to stress the RAM, 1 to stress the SSD storage, and GPU test, mathematical one, and practical to create real image.
Let me explain everything in more details. Python. CPU tests. First, arithmetic stress test. What it does. It runs a series of complex mathematical operations, such as trigonometric and exponential functions repeatedly. The purpose is to maximize the CPU's floating point calculation power by processing billions of operations in parallel across multiple CPU cores. This test is optimized for heavy arithmetic workloads. Real-life analogy. Think of this as a computer system running repetitive, high-complexity calculations that keep pushing the CPU until it's fully stressed to keep the task running, until it's fully processed. Second, prime number stress test. What it does. This test checks whether a series of large numbers are prime by performing a series of modulus checks and prime finding algorithms. It tests the CPU's ability to process large numbers and perform intensive mathematical checks across a range of values. Real-life analogy. Imagine an IT worker trying to figure out if a large set of numbers have a specific property. In this case, if they're prime, which requires a lot of processing power to check each number individually, analyzing the dataset and searching specific characteristics inside it. Fractal stress test. What it does. This test renders parts of the Mandelbrot set, a famous fractal. It performs complex mathematical operations for each point in the space, repeatedly iterating for each. This test uses large-scale parallel processing to compute intricate patterns in the set, which requires substantial computational resources. Real-life analogy. Think of this as in scientists trying to generate an incredibly detailed fractal image, using advanced math at each pixel to determine whether it should be part of the fractal set or not.
Let me give you an example of how it can be used. Arithmetic test. Our distant future, year 2084. A psychic investigator is called to solve a mysterious mental block that has trapped an individual in an infinite loop of contradictory thoughts. His psychic brain implant is pushed to its absolute limits as they run through calculations of thought processes, systematically attempting to break the mental loop. Oh, a massive urban surveillance AI is tasked with maintaining optimal traffic flow across the city. It processes billions of data points per second, vehicle speeds, road conditions, accidents reports, constantly running arithmetic algorithms to adjust traffic lights, reroute vehicles, and predict the next congestion hotspots, ensuring the non-stop flow of the city. Or, across the far reaches of space, an intergalactic economy system monitors the flow of resources, investments, and materials. As trillions of operations are processed per second, billions of trade routes are simultaneously optimized. Each transaction is calculated with the precision of a universal clock. Every error, every fluctuation in the system ripples out across the system, requiring constant recalibration. The entire system runs on parallel operations, executed across thousands of planetary hubs. The balance of the galaxy depends on these calculations. Prime numbers test. A cryptologist working on an ancient archaeological society stumbles upon an encrypted manuscript filled with coded numbers. The manuscript is rumored to contain a secret map to an ancient civilization's lost treasure. The operator must sift through trillions of numbers, testing and decoding patterns that could reveal hidden messages. The cryptologist's CPU is pushed to the brink as it runs calculations to break the encryption, revealing the treasure's location. Oh, futuristic megacorporation. Sensitive client data is encrypted using vast arrays of prime numbers. The corporation's security system is under attack by rival hackers attempting to brute force their way into the encrypted world. To guard the intrusion, the corporation's AI must constantly generate and verify numbers, scrambling and re-encrypting data at lightning speeds. The CPU runs an endless loop of prime checking, generating keys faster than the hackers can break them, ensuring the protection of confidential corporate dark secrets. Oh, across an interstellar fleet, starships rely on quantum encryption based on prime numbers to communicate across vast distances. The encryption must be constantly recalculated to prevent interception by enemy factions or hostile alien species. Central Galactic AI processes trillions of numbers to ensure that every transmission is secure. The CPU must operate at full capacity, constantly recalibrating encryption algorithms as ships travel through wormholes where electromagnetic distortions can impact signal integrity.
Is this a sci-fi fan meeting? Or computer benchmarking?
Shut up. Let me finish. Fractal stress test. A virtual reality architect of immortal race is tasked with creating the most complex, immersive mortal world ever designed. The world is rendered using the fractal set, with each pixel containing endless depth and complexity. The architect system runs millions of iterations to generate an infinite, self-replicating landscape, creating a truly boundless virtual environment. As the system pushes its limits, the architect explores the mathematical beauty of the fractal, fine-tuning the virtual reality experience with a limitless array of new worlds to discover. Oh!
Yawn. I am sleeping.
At the heart of a dystopian metropolis, a cruel AI system renders real-time simulations of urban life. Every street, every building, every human interaction is modeled using the fractal complexity. The system iterates over vast datasets, calculating the future of the city's growth, simulating traffic, predicting infrastructure needs, and analyzing human behavior. The city relies on these computations to remain efficient, but the complexity of the task causes the system to operate at maximum capacity. The AI uses its parallel processors to run millions of iterations. It all shapes citizens' destiny to ensure the city continues to function, no matter what. And finally, on a planetary scale, The fate of entire civilizations is calculated by a super-intelligent network that uses the fractal set to simulate the behavior of galaxies, star systems, and interstellar travel. Each pixel in their simulation represents a part of the universe, and the network runs millions of iterations to predict and model everything, from the birth of stars to the fate of entire civilizations. These calculations are necessary to understand cosmic patterns, predict catastrophic events, and safeguard the future of endless worlds.
Did you finish?
It was a CPU test. I have designed 2 tests for RAM and for SSD. What does RAM test do?
Allocates very large arrays of doubles, splits them into chunks based on available system memory, repeatedly fills chunks with random values, forces page faults, optional memory access forcing, runs heavy floating point math loops, processes data in parallel. What does it stress? RAM capacity. How much memory can be allocated? Memory bandwidth. How fast data can be read and written. CPU plus memory interaction. Cache pressure. Thread scaling. Page fault handling. Forcing memory subsystem pressure. Detect unstable RAM and overclocking issues. Validate memory subsystem throughput. Test system stability under near conditions.
Sounds boring. What about disk test?
Creates a large temporary file. Writes it sequentially in chunks. Reads it back sequentially. Performs random access. Reads and writes. Key behaviors. Large sequential write. Tests max disk speed. Sequential read. Tests read bandwidth. Random access loop. Tests worst case latency patterns. Real purpose. Benchmark real disk speed under sustained load. Detect SSD throttling. Test file system stability under heavy I/O.
And only on Python and C++, I have a VRAM mathematical torture. GPU test uses universal OpenCL, which can be used on each and every system, device and computer, but can be a limiting factor. I tried to make this test universal for OpenCL, and second, more optimized for native environments. I started to design similar tests for NVIDIA CUDA, Intel One API, AMD ROG M, and Metal GPU for Apple, but was successful only on NVIDIA CUDA. Others need a very in-depth and too overcomplicated proprietary constraints. Especially Apple. It is outside of the scope of this small test. So there will be only universal OpenCL test. What it designed to do?
Initializes OpenCL. Detects GPU and VRAM size. Allocates large GPU buffers. Runs a custom GPU kernel. A massive floating point math engine is processing meaningless but expensive computations across millions of threads. Real purpose. Test GPU stability under compute load. Not gaming load. Detect overheating and throttling. Validate OpenCL driver stability. Benchmark raw compute throughput.
So, in the end, we have 3 mathematical tests for CPU. 1 for RAM, 1 for SSD, and 1 for GPU.
All 4 together form a full system stress suite. CPU, mathematical computation plus threading. RAM, allocation, bandwidth, cache pressure. Storage, sustained I/O plus random access latency. GPU, parallel compute plus VRAM bandwidth. They are designed to maximize hardware utilization across all subsystems simultaneously until physical limits are reached.
It was Python. Next will be C++. And we got everything exactly the same, but by using C++ tricks and environment-specific tools, and with embracing these codes' language-specific limitations. Same 3 CPU tests: arithmetic, prime numbers, and fractal math, RAM, SSD, and GPU VRAM stress. Next will be Java. Java has its own, very annoying limitations that I needed to work around. It will be slightly different. There will also be the same 3 CPU tests, fractal and prime numbers. But instead of first arithmetic one, it will be called branches CPU test. What it does?
It is a very interesting CPU workload, because it is fundamentally different from arithmetic and prime tests. This test is a branch-heavy, instruction flow chaos generator designed to maximize CPU control flow pressure, rather than raw math throughput. Instead of doing heavy floating point math, it focuses on unpredictable execution paths, frequent conditional branching, state mutation, instruction pipeline disruption. It runs multiple threads using a work-stealing pool, where each thread repeatedly processes random values and mutates a shared state through a deeply nested switch statement. Each thread generates a random 64-bit state. The state is repeatedly modified inside a loop. A switch selects one of several bitwise arithmetic operations. Each branch changes the execution path every iteration. Work is split across multiple CPU threads. Progress is tracked using atomic counters and periodic logging. What does it represent? This test simulates workloads where execution flow is unpredictable, such as interpreters and virtual machines, firewall, routing logic, decision tree systems, event-driven backend services. It stresses the CPU by making execution unpredictable, branch-heavy, or at least difficult to predict or optimize.
Let me show the examples. A fate analyst works inside a predictive cognition system designed to simulate possible human destinies. Every input, emotion, choice, environment variable is treated as a branch point in a probabilistic future map. Each evaluation does not produce a single outcome, but splits into multiple potential life trajectories. The analyst must continuously process divergent paths: success, failure, survival, disappearance. Each recalculates as a new data arrives. There is no single fixed future, only constantly shifting branches of possible destinies, collapsing and reforming under real-time computation. Oh! A metropolitan governance system runs continuous simulations of city stability under unstable policy conditions. Every input, economic change, civil unrest, infrastructure failure, forces immediate branching into multiple response models. Each department evaluates different strategies simultaneously: enforcement, adaptation, shutdown, or expansion. No single directive remains valid for long, as each decision creates new secondary consequences that must be recalculated instantly. And finally, a planetary-scale command intelligence governs a network of colonies, fleets, and autonomous systems across multiple star systems. Communications are delayed, conditions are uncertain, and every incoming signal can alter the entire strategic path. Each command is not executed directly, but expanded into branching response trees. Defensive protocols, resource distributions, evacuation scenarios, and diplomatic countermeasures. The system does not follow a single timeline. It continuously diverges into multiple possible futures, collapsing and recalculating them in real time as new data arrives. So, in Java, the only difference will be this branch's CPU test and the absence of GPU VRAM mass test. It had some problems on Java, and instead I have prepared something better.
What will the length of this video be? Is all that necessary? Do people even code today? There will be a couple of people left at this point. Finish fast!
Abstract mathematics is cool and dandy, but I want to create something physical. For each coding language, I have designed a unique GPU test on OpenCL that will produce real physical files, images, and animation. For Python, GPU test called matrix patterns. Code will produce me the looped animation of 33 images of green symbols, mesh, and grid based on mathematical equations, urbanistic and futuristic. For C++ coding language, I made a test called ether signals. Code will produce me an animation of 33 frames of psychedelic fluctuations of electromagnetic ether, a field out of which all chemical elements are created, the son of gods. And for Java, there is something special: 4 unique GPU tasks that creates a dedicated image. First one is called Galaxy. It gives me a high-resolution picture of emergent fractal-like cosmic objects called Julia set to research the formation of galaxies and nebulas. Second one is called Soul. This code gives me a high-resolution image of galactic star formations that is called Buddha-Brod, a constellation that contains a soul of a high-state being. Third one is called DNA. Code gives me a high-resolution picture of Mandelbrot, a fractal geometry on which DNA of living beings from flesh were coded. And the last, fourth test is called Matter. This code gives me a high-resolution image file of a blobby 3D fractal located in the 3D space. This fractal is known as Mandelbulb, to research the repeated patterns of matter and flesh formations from DNA source. So, that's it for dedicated handcrafted coding tests. All what you have witnessed above, all tests on Python, C++, and Java, will be done in 3 levels of difficulty: easy, medium, and high. The difference will be the amount of work and data that each test need to process. Thus, the amount of time and hardware requirements are increased on each level. So, 69 runs on each device. Even more if we take into consideration turbo, balanced, silent, and silent plus iGPU. Yeah, lots and lots of reruns.
Fine. Will there be any bonus rounds? I am scared to even ask.
Of course it will be, but this time, little bit different. Hardware performance from coding is very interesting, but most of the time, the code is lightweight, and person spends most of the time just typing it on a keyboard, staring at the screen and trying to problem solve. Usually to make these boring sessions more relaxing, a person can open a web browser to watch a movie, video, listen to a podcast and music. Maybe at the same time, he has some other apps and images open in the background. And the overall system speed, snappiness and stability is more important than raw hardware powers. That's why I want to test a Speedometer 3.1. This app simulates browsing experience by loading, opening, closing lots of web pages and going through lots of data to test system snappiness. But I do not care about sterile lab conditions. I want to stress test and torture the system. I want to know how will it behave under heavy load. I will run Speedometer 3.1 3 times, but with 15 browser tabs opened, one of which will be online card game, with 2 4K YouTube videos running, with video file running on loop, with music file running in the player, and with 1 instance of Photoshop with image loaded into it. This is what I call system loaded. And if you think that it is too much, I usually use more tabs and more programs are opened during my daily use. So no, this test is more than reasonable enough. For the proper testing, I will do it in all modern popular browsers, in Microsoft Edge or Apple Safari, in Chrome, Brave, Opera, Yandex, and finally Firefox. 6 browsers in total. And for even more proper testing, it will be done in Turbo, Balanced, Silent, and Silent Plus iGPU modes for laptops, 3 times in a row to find an average value, 72 runs on each device, and 24 results to analyze. This test is designed to show the overall system stability, responsiveness and snappiness, not only during coding sessions, but in general during any computer usage. The whole coding section has tasks that need some time to be finished. Thus, the faster, the better. The shorter graphs show the best results. And bonus, Speedometer 3.1 has numbers. The larger the number, the better the results. Thus, longer graphs reveal the more powerful device.
Finally! I thought you would go forever. Who cares about coding? Next! 9th circle. Game development.
Transitioning from coding languages into real-world application of code. In this section, I will test game dev on 2 programs, Unreal Engine, and as bonus round, Unity. Let's start from Unreal Engine. I will test 3 games for easy, toaster, medium, human and hard, alien level. First will be small indie game project, crop out, low size, lightweight and easy on system. Second game, more advanced, Lyra project, first-person online shooter, bigger file size, more stress on system. Third game, epic project. It is called Valley of the Ancients, AAA demo that uses all modern bells and whistles of Unreal Engine, nanites, lumens, and can put even modern systems on its knees. The largest file size and more stress on hardware. As a bonus, I will test Unity, game project called Spaceship, a medium-sized demo with modern graphics.
How are we gonna test it?
First of all, I will export a playable first build of a project that recompiles everything from scratch. In Unreal Engine, it is called Package Project. It takes some time. Next, I will rebuild or repackage the project second time. Usually when you make some changes, you do not want to rebuild all the files from scratch, so further builds will be faster. And third, finally, I will test preview work window performance, just by measuring the FPS of the viewport. The comfort when working on your project is very important, if not the most important factor. So, first build, second rebuild, and viewport FPS. Easy. For toaster level, I will test indie crop out. For human level, I will test advanced Lyra and Unity Spaceship. For alien level, I will test epic Valley of the Ancients. Build and rebuild of the project takes some time, so faster it finishes, the better. While FPS in the viewport is opposite, the higher the number and the graph, the better.
That was fast. Next. We came out of main boundaries. 10th circle. Gaming.
Initially, I thought to make gaming a separate video, but it will be unnecessary and confusing. I want everything to be in one place. Just use timestamps. This video is an in-depth guide and explanation. All my other reviews and computer battles we'll just show results and graphs. All the context will be here and here only.
And how are we gonna test games?
I hope it won't take too long to explain. There will be 3 sections. First, synthetic gaming by using dedicated benchmarking 3D software. Second, real gaming, where I will use full real retail games. And third, system stability while gaming.
Now in more details.
Synthetic gaming. Initially, I used 2 programs for that, GFX Bench and 3D Mark. Unfortunately, not so long ago, this year, GFX Bench, after 2 decades, went out of business and shut the servers down. Goodbye, my friend. Aztec ruins will forever be in our hearts. So, the only solution that left is 3D Mark. I will test 4 games. First, Wildlife on 2.k resolution. Wildlife Extreme on 4K. Second, Time Spy on 2.5K. Time Spy Extreme on 4K. And third, Firestrike on 2K resolution. Firestrike Extreme on 2.5K. Firestrike Ultra on 4K. Bonus game will be Solar Bay on 2.5K for ray tracing performance. I will ignore all graphs, scores, except raw FPS numbers. It is the only indicator that interests me. We will use 3D Mark dedicated 20-run stress test on stability test for more. So, for toaster level, I will use Firestrike 2K and Wildlife 2.5K. For human level, I will use Wildlife Extreme 4K, Time Spy 2.5K, Firestrike Extreme 2.5K, and Solar Bay. For alien level, there will be Time Spy Extreme 4K and Firestrike Ultra 4K. Let's not overcomplicate things for now. That's all for synthetic gaming. It is just a warm-up for real tests. Let's play some games. In real gaming, we will test 6 games in 3 sections. 18 games total, plus 1 bonus, so 19 games. After that will be small DLSS and frame generation section. And finally, stability, where we will check turbo, balanced and silent modes, 1% lows for stutters and lags, and 20 runs stress tests on 3D Mark software. All these games from first to last becomes progressively more hard and demanding.
Light category, 6 games. Half-Life 2, Lost Coast, Alien Isolation, Tomb Raider, BioShock Infinite, Counter-Strike 2, Warhammer 40k, Dawn of War 2. Medium category, another 6 games. Forza Horizon 4, Grand Theft Auto 5, Dirt 5, Shadow of the Tomb Raider, Horizon Zero Dawn, Metro 2033. And last, heavy category, 6 more games. Deus Ex, Mankind Divided, Callisto Protocol, Red Dead Redemption 2, Talos 2, Black Myth, Wukong, Cyberpunk 2077. All games will be tested in 4 different resolutions. In 2K, so-called 1080p, 2.5K, so-called 1440p, in 4K and 8K. And on top of that, in 3 different quality presets, in low, medium, and ultra. So each game will be tested 12 times. Considering that we have 19 games total, it will be 228 runs of tests. I do not even include turbo versus balanced versus silent, iGPU, dedicated DLSS tests. In other words, gross. So, how are we going to gather the results?
It is complicated, but it has to be. For easy toaster level, I will use 6 lightweight games, up to 4K on low settings, up to 2.5K on medium, and only 2K on ultra. Also on medium category, we can use 2K on low settings as well. Why not? I expect nothing less even from a toaster. That's all for toaster level. For medium human level, I will use lightweight games, 8K resolution on low settings. Medium games, I will use up to 8K on low settings, up to 4K on medium, and up to 2.5K on ultra. In heavy games category, I will use up to 4K on low settings, up to 2.5K on medium quality, and only 2K on ultra. That's all for human level. For alien level, I will use 8K on ultra in lightweight games, medium category, 8K on medium quality preset, and 4K and 8K on ultra preset. On heavy games category, I will use 8K on low quality, 4K and 8K on medium quality, and 2.5K, 4K and 8K on Ultra preset. That's all for Alien level. Of course, we will test some games on turbo, balanced and silent presets of laptops. For that we will use Deus Ex, Mankind Divided, and Alien Isolation. And bonus round. Can it play Minecraft? 19th, a game will be Minecraft, as a small bonus. Minecraft does not have conventional low, medium and ultra graphical presets, so I decided to create my own. For low settings, I will use baseline Minecraft as it is. For medium quality, I will use shaders to enhance graphical fidelity and make it very pleasing for an eye, and more taxing for a system. And for ultra preset, on top of shaders, I will install add-on called Distant Horizons. It removes the limits of how far you can see, making vision almost endless, with beautiful open horizon view, while hardware performance drops drastically. Testing logic is applied as if Minecraft is for medium game category.
Is there anything else?
Of course, I will also test DLSS and frame generation. For that, I will use two heavy games, Cyberpunk 2077 and Talos Principle 2. DLSS is a tricky, clever resolution upscaling method, while frame generation analyzes multiple frames and puts a couple of generated fake ones in between with the offset, left, right, up and down. It can lead to some artifacts and distortions, but usually when playing at high speeds, it is not noticeable. But all this comes with a price, more latency and reduction of responsiveness. It means that there is a delay between pressing of a button and what happens on your screen. It leads to less comfortable and less snappy experience, especially in online games. But with more frames, perceived image becomes smoother, even though it is fake and less snappy. For each device, I will try to use the best method available at the moment of testing. Usually, it is NVIDIA DLSS or AMD Fidelity FX if not, with frame generation turned on. I dislike this feature and will use only two games just to showcase of what is possible. So, obviously, the more FPS, the better, so longer graphs will show more powerful computer. As for the cursed debuff system, if game constantly crashes, it will get flat minus 60 FPS. If device crashes the whole system and it needs a reboot, or if it cannot run specific settings or resolutions at all. For example, like Apple MacBooks do not have 8K support for some models, it will get flat minus 120 FPS as a debuff.
But what about stability? It is a very important factor. Who wants to play with constant freezes and stutters?
For that matters, I chose 3 games from all 3 categories: Counter-Strike 2, Doors 5, and Talos Principle 2. I will gather 1% lows data and compare the percentage difference with average FPS. That way we will understand the stability of the game. What is 1% low? Sometimes game can have dips in performance. Visibly it looks like microfreeze, lag or stutter. When this event happens, game gathers information as the average frame rate of the slowest 1% of frames during gameplay. In other words, if average frame rate is 240 FPS and 1% low is only 40 FPS, it means the system is laggy, while if 1% low is 200, it means that performance is very stable and your experience will be smooth. 1% lows must be as close to average FPS as possible. Second, I will use 3D Mark software with its built-in stress test benchmarks. I will use 2 benchmarks, Wildlife Extreme and Solar Bay, both for 20 runs stress test. We will get maximum score, minimum score, and stability between them in percentage numbers. So, 3 real games and 2 synthetic stress tests will reveal what device is more stable and will give more comfortable gaming experience. When it comes to laptops, I will test it in turbo and balanced plugged in, and on normal on battery, as well as on silent with iGPU only. It can provide a lot of insights of what to expect from each system. All gaming tests from synthetic to real and stability tests provide data with numbers. Higher number is better, as well as longer graphs are.
Finally! What the actual freak! You are the maniac. Let's go the next circle and you will give your conclusions.
11th circle, battery life, fan noise and temperatures. This section is only applied to laptops. Desktops are out of this test for obvious reasons. For the battery life, I have a 4-step stress test. I set the device in balanced mode, turn on Bluetooth and Wi-Fi modules, and make screen 100% brightness with all refresh rate possible. It is not fair, because each device has different brightness levels and refresh rates. But we are buying the machines as a whole package, as it is. With exactly that settings, no one in the field will dim the screen with luminance meter. We are just increasing brightness to 100%, or lowering it to 50% and so on. This test physically cannot be fair, and should never be. All the devices has its own upsides and downsides. It is just life.
First step, unplug the device and record the screen in OBS in 1440p 60 FPS, in H264 codec with 100 megabit bitrate. For 20 minutes, write down how much battery left. Second step, run Wildlife Extreme Stress Test. 20 runs, write down battery numbers. Third step, playback 4K 30 FPS video file for 20 minutes. Write down what's left. Fourth step, run solar-based stress test for 20 runs. And finally, we have 4 measurements of what is the battery drain and what's left in the end. If the device is left with more than 70% battery life, there will be 5th secret step. Time SPY stress test, 20 runs until it goes below 50%.
Second run, I turn dedicated GPU off and use only integrated in the CPU. Switch device into the silent or eco mode. Turn both Bluetooth and Wi-Fi off. Set brightness of the screen to 50% and change the refresh rate to 60 Hz. This run is designed to show what we can get if we are ready to sacrifice performance and comfort for the sake of longer battery life. And I will repeat all 4 steps to get the battery life drain data. In the end, we will know what to expect if we use the device on battery at full power and on full economy mode. Next, fan noise. I try to record the audio of fan noise while I run the stress test to compare to other devices, but also, if possible, I try to manually set fan to low 2000 RPM, medium 3000 to 4000 RPM, and heavy the maximum RPM the device can give. But not all laptops allow to manually control the fan, so it depends on each situation. And temperature. During stress test, I record the heat from the thermal camera. First, I get the CPU report temperature from the app. Next, I manually record temperature of the touchpad, keyboard, and finally, the hotspot. So I can understand what to expect in terms of comfort for hands.
It was wild!
It is not all. Bonus 13th circle.
What? Kill, pain, violence, freak, die. Are you serious right now?
More than yeah.
You will get one person at best that will watch till this part of the video. And why you have called it 13th? Previous circle of tests was 11th.
Do not ask me stupid questions. Bonus test is sound quality and speakers. I record 7 music tracks in identical conditions with stereo microphones, with unified volume based on laboratory measurement, so perceived loudness is the same across all devices. First track, Vivaldi, Spring. Eternal masterpiece for classical music. Other 6 tracks are handmade by Mr. Alien. Eternal Fire for rock. Reflections of Tomorrow for trance. Beyond the Nature for low and bass. And 3 more, just for fun. Desert Dune. Cosmic Signals. And the track named Alien Technologies. Even budget laptops must have good quality speakers. Audio is solved 100 years ago. Good speakers are cheap nowadays. The only reason to put garbage trash inside a laptop is to divide products and people into poor and rich. It is unacceptable, and I will fight for the good audio till the reboot of the universe.
Are we finished? I need some coffee. And I really need to go and do analysis of your illegal biological experiment on doppelgangers.
Do not spoil us, stupid metal sheep.
You know, it is rude. I have soul. that you leaked out of my previous body. Do not be so cocky!
How many times you will repeat this? It was 2000 years ago. There was no other ways. We need to finish this video.
Human voice mimic system initiated.
So, thank you my friends for watching this real alien computer testing. This guide explains what all the graphs and benchmark mean in all my laptop and desktop reviews. I will leave a link to it under every video. People's attention span became too short. I will have to somehow make it shorter. Some of the stuff will be only for Patreon members to watch, but more than 90% will be free for YouTube. I need to find a way to make it as compact and straight to the point as possible. Have a very cosmic day.
And thank you for visiting Alien Technologies channel.